Hey guys, today we'll be talking about the domain and range of functions. So be sure to write down today's FLT. Given a function, I will be able to identify the domain and range analytically, so algebraically, and or graphically. So first, let's focus on the domain. So the domain is the set of all possible x values. What do we mean by possible? So all possible values. So for example, imagine you're trying to calculate someone's speed when they're running. It would make sense to be like, 1 mile per hour or like 5 miles per hour. But it wouldn't make sense to be like, this guy runs at 60 miles per hour or at negative 30 miles per hour. It's just not possible. So same thing with domain. We only look at x values that are possible in that given function. And there are two considerations to make, or two restrictions, when thinking about the domain. The first restriction is that you cannot divide by 0. So you can't have something like 5 divided by 0 because that would lead to an undefined answer. If we have a fraction, we have to make sure the denominator does not equal 0 because if that happens, then you're trying to divide by 0, which you cannot do. The other restriction is that you cannot take the square root of a negative number. So for example, you cannot take the square root of negative 3. I know in our earlier lessons we talked about complex numbers or imaginary numbers where you can take the square root of a negative number, but in the real world you can't. And today we're just focusing on what's real. So with these restrictions in mind, let's take a look at some examples. For our first example, let's find the domain of the function y equals 6 over x plus 2. I ask myself two questions. Are there fractions? And are there square roots? In this case, we have fractions. Based on the restrictions, we have to make sure the denominator of this fraction does not equal 0. So we have to make sure that this x plus 2, the denominator, does not equal 0. So let me write it out here. X plus 2 not equal to 0. And then we're going to solve for x. Subtract 2 from both sides to isolate the x, and we're left with x cannot equal negative 2. So when you think about the domain, think about having like a number line where you start from the left. So you start from negative infinity all the way to the right, so positive infinity. And then from here, you think of all possible x values. In this case, we know that x cannot equal negative 2. So x can be any value but negative 2. So for the domain, we can start at negative infinity and then hop over negative 2. And then after that, keep going all the way to positive infinity. So how would we write this as our domain? So we write it as an interval. So the domain starts at negative infinity, and we can go all the way to -2. So right here, -2. But then we had to jump over it. So we're going to use this little symbol, it's actually called the union symbol, to show that we hopped over it. And then we resumed right after -2, all the way to positive infinity. So this domain tells us that we can go all the way from negative infinity, so really small number, all the way up to just a tad bit before -2, and then we hop over -2, and then we can resume right after -2 and go all the way to infinity. So this function works anytime except for when x equals -2. So this thing I wrote out here is called interval notation, which is what we'll be using to express our domain. So we have the interval notation. And this symbol in the middle that looks like a U is our union symbol. So it's kind of like a mathematical version of AND. So for the next example, let's find the domain of the function y equals 8 over x minus 3. Again, I ask myself if there are fractions or square roots. And in this case, we have fractions. So we have to make sure that the denominator does not equal 0. So we have to make sure that this x minus 3 does not equal 0. So let me write it over here. X minus 3 not equal to 0. And then let's solve for x. How do we isolate x? So we add 3 to both sides. This cancels out, and we're left with x cannot equal 3. I'm going to draw a number line to see what the domain looks like. Our number line starts at negative infinity, goes all the way to infinity. But notice in this case, x cannot equal 3. So let me label that here. So for our domain, we start at negative infinity, go all the way to just a tad before 3, hop over, and then move on right after 3. So our domain would be starting at negative infinity to just a little before 3, and also a little bit after 3, all the way to infinity. So for this function, any x value would work except for 3. On Edpuzzle, please find the domain of this function. Y equals 10 over x plus 8. For our fourth example, let's find the domain of the function y equals 12x plus 5 over x minus 2 times x plus 6. Even though it seems like there's a lot more going on right here, we're still just focusing on the denominator. So for this one, you can kind of ignore the numerator, 12x plus 5. We just focus on the denominator. So we have to make sure that x minus 2 times x plus 6 cannot equal 0. Notice how this is similar to the zero product property setup, which we talked about back when we were factoring polynomials. That means I have to set x minus 2 not equal to 0, as well as x plus 2 not equal to 0. So let me just write that on both sides. And go ahead and try solving for x on your own, and then press play to compare answers. So for this side, I add 2 on both sides, and I'm left with x cannot equal positive 2. On this side, I subtract 6 from both sides, and now I know that x cannot equal negative 6. So I have that x cannot equal 2, and it also cannot equal negative 6. So what would this look like on our number line? Okay, so I'm going to write out the usual number line, starting at negative infinity, going all the way to infinity. But now I have to skip over both negative 6 and positive 2. So starting from the left, I hop over negative 6, and I also hop over 2. And then after that, I go all the way to infinity. So how would I write out my domain? I start at negative infinity, go almost to negative 6, and then resume right after negative 6 up to right before 2, and then after I hop over 2, I can go all the way to infinity. So notice in this case for our domain, it's all possible x values except negative 6 and 2. On Edpuzzle, please find the domain of the function y equals 16x plus 4 over x plus 6 times x minus 1. So before we move on to more examples, let's quickly focus on this word right here, radicand. So the radicand is anything inside the square root. So if we had the square root of 3, your radicand is 3. And for the square root of x plus 4, your radicand is x plus 4. And so as a restriction, this radicand cannot be negative. In other words, the radicand must be greater than or equal to 0. So for our 6th example, let's find the domain of the function y equals the square root of x plus 4. Notice here we don't have fractions, but we do have square roots. We have to make sure that the radicand is greater than or equal to 0, since it cannot be negative. I subtract 4 on both sides, and so x is greater than or equal to negative 4. So in this case, what would our domain look like? I draw out my usual number line, going from negative infinity to positive infinity. And then I'm also going to jot down the negative 4. x is greater than or equal to negative 4. So we start right at negative 4 and then keep going all the way to the right. Notice that we can't have any x values less than negative 4 because then the radicand would be a negative number. We can't have that. Like for example, if we had x equals negative 10, then our radicand would be negative 10 plus 4, which is negative 6. Yeah, that doesn't work because it's negative. So x has to be greater than or equal to negative 4. And notice right here, we're actually touching the negative 4 this time. We're exactly on negative 4. So our domain starts right at negative 4. This bracket shows like right at, and then going all the way to infinity. So this bracket right here shows that negative 4 is included in the set. Whereas if you had a parentheses negative 4, that would mean you can only go super close to it, but not right to negative 4. So in this case, any x value starting at negative 4 or larger would work for a function. So our domain starts at negative 4 and goes all the way to positive infinity. And then this bracket right here is called a closed interval, which again shows that we include the negative 4. Whereas this side is open because technically you can approach infinity but never actually reach it. Next, let's find the domain of the function y equals the square root of negative 3x minus 9. So notice here we have a square root. So we have to make sure the radicand, so the negative 3x minus 9, is not negative. So we have to make sure that negative 3x minus 9 is greater than or equal to 0. And let's solve for x. First, I add 9 to both sides, so I have negative 3x is greater than or equal to positive 9. So I divide both sides by negative 3. And do you guys remember what happens when you divide both sides by a negative? So what happens to the inequality right here? The inequality is going to flip. So we're going to have x is less than or equal to negative 3. Again, it's less than or equal to because the sign flips when you divide by a negative. So what is this less than or equal to negative 3 going to look like on our number line? So I have my number line going from negative infinity to infinity. And then what happens at the negative 3 mark? So since x must be less than or equal to negative 3, it can be anything smaller than negative 3. So like negative 5, negative 100, negative 1000, all of those are okay options. So we start at negative infinity and then move all the way to negative 3 and stop there. So I stop right at negative 3. So how would I write this in interval notation? The domain is anywhere from negative infinity all the way to exactly at negative 3. So in this case, the function would work anytime x is less than or equal to -3. Please try this one out on Edpuzzle. Find the domain of the function y equals the square root of 3x plus 15. Just as a reminder, you only have to flip the inequality if you're dividing by a negative. For our next example, let's find the domain of the function y equals the square root of x over x minus 2 and then plus 7. Here I have both a fraction and a square root, so I have to think about two restrictions. I have to make sure the denominator does not equal 0, and I have to make sure that the radicand is greater than or equal to 0. And that positive 7 or the plus 7 right here, this is just kind of lingering, so we can just ignore it when we're thinking about the domain. So our denominator here is x minus 2, and our radicand of our square root is x. So first, let's focus on the denominator. X minus 2 cannot equal 0. I add 2 to both sides, and I find that x cannot equal positive 2. I have to make sure the denominator does not equal 0. I also look at the radicand, so x must be greater than or equal to 0. But x is already isolated, so that's all we have to do here. I draw my number line, and here I'm going to have two numbers to focus on. So I have that 0 right here, and we also have to remember something about the 2. So let me write that over here. So what would our domain look like on this number line? We know that x is going to be greater than or equal to 0, and we also know that x cannot equal 2. So we start right at 0 and keep moving to the right, but we have to hop over 2 and then keep going all the way to positive infinity. So our domain, or our possible x values, starts right at 0. So I'm going to use the closed interval like this. And we go right before 2, hop over 2, start right after 2, go all the way to infinity. And so we have our domain here. Notice in this example, we had to consider both the fractional restriction and the square root restriction. For this example, let's find the domain of the function f of x equals the square root of 2x over x squared plus x minus 20. I know this might look confusing at first, but let's break it down together. Notice we have both a fraction and a square root, so we have two considerations to make. We have our denominator, x squared plus x minus 20, and then our radicand is 2x. So let's focus on the denominator first. X squared plus x minus 20 cannot equal 0. So a few weeks ago, we looked at how to factor polynomials. Guess what? It's back! So go ahead and try to factor these polynomials using the method of exhaustion. So go ahead and try it on your own, and then press play when you're ready. It should look something in this form. So I got this combination, x plus 5 times x minus 4 cannot equal 0. And if you're unsure of how we got this combination right here, remember you can always reach out to me on Remind. All right, so two potential x values, x plus 5 cannot equal 0, and x minus 4 cannot equal 0. For this one, subtracting 5 on both sides, so x does not equal negative 5. Over here, adding 4 to both sides, so x also cannot equal positive 4. And so let's look at the other restriction, the radicand. 2x must be greater than or equal to 0. I divide both sides by 2. And so x must be greater than or equal to 0. So what does this look like on the number line? So I'm just going to write down like the important numbers. So I know x is going to be greater than or equal to 0, and x cannot be negative 5, and it also cannot be 4. All right, so x has to be greater than or equal to 0, and also x cannot be negative 5 or 4. So we start at 0 since x is greater than or equal to 0, and we move to the right, hop over 4, and then move on all the way to infinity. So let's write it in interval notation. Our domain starts at 0, goes really close to 4, but we hop over it, resume right after 4, and then move on to infinity. So our domain is written like this. And notice how we didn't even bother with the negative 5, since it's not greater than 0, it's less than 0, so that number wouldn't work anyway. So we basically kind of ignored it. This is your final example for the domain part. Please find the domain of the function g of x equals the square root of 5x over x minus 6. All right, so we covered the domain. Next, let's take a look at the range. So the range is the set of all possible y values. So we ask ourselves, how high can we go and how low can we go? And we're going to find the range by looking at graphs. So for the first example, let's find the range of the function y equals the square root of x plus 3. At this point, you're not expected to know how to sketch this graph yet, so don't worry. But I'll just do a quick sketch. You can always also just use Desmos for now. So what happens here, I start at negative 3, and it's this weird curve thing. And then focus here on the starting point. The coordinate for this starting point is negative 3, 0. And for the range, we only focus on the y value. So in this case, it's 0. So notice how the graph starts at 0 and it keeps going up forever. It doesn't really hit anything. So this tells us our range. Our range starts right at 0 and goes all the way to infinity. So like we did right here, we can find the range by looking at a graph of the function. For our next example, let's find the range of the function y equals negative absolute value of x, and close the absolute value, plus 3. So we've actually talked about how to sketch these types of functions in the past. So go ahead and try sketching it on your own, and then press play when you're ready to compare answers. So for this function, let me sketch it out. Okay, so the k value is +3. And notice that we reflect across the x-axis. So it's going to be a flipped V shape, like this. And like I wrote, the vertex is at 0, 3. So we focus on the y value, which is 3. So notice for this graph, this V shape, the backwards V shape, will go down all the way to -infinity. But when it's moving up, it can't go higher than 3. So the range is going to start at -infinity and go all the way to 3. And we used a closed interval here. And here's our range. And in case you were curious, let's also look at the domain. Here, any x value is possible for this function. So anything from -infinity all the way to infinity. We can also just use this fancy R to denote the domain. And this fancy R stands for all real numbers. So let me just write that down here. This fancy R stands for all real numbers. Okay, so here is your final example for today. Please find the range of the function y equals x squared plus 2. Go ahead and try sketching it on your own first, and if you want to check your answer, you can use Desmos. As a review, the domain of a function is the set of all possible x values. And be sure to remember these two restrictions when finding the domain. You cannot divide by 0, and you cannot take the square root of a negative number. And the range of a function is just the set of all possible y values. Please remember to submit your notes on Canvas, and see you guys next time.